welcome back to freehighschooleducation.com. Today we are going to do chapter 9.5 in Algebra 1, page 359. Problem solving, work problems. These are work-related problems. Here we are going to use this equation. Work equals to rate times time. Here the work done usually is 1 because we are dealing with one job at a time. The rate is the rate of doing the work, and the time is the time it takes to do that job. So let's see how we apply this equation. Example 1, Frank can type a report in 5 hours. So his time to finish the job is 5 hours. Now if I want to find the rate, I put 1 here, equals to rate times 5, and rate will be 1 over 5. Now what part can he type in 2 hours? I just want to know in 2 hours how much he can finish of the job. Now I apply the same equation again, and I know his rate is 1 over 5, and now I want to see how much he can do in 2 hours, and here I put times 2, and I get 2 over 5. So he can do 2/5 of the job in 2 hours. Now if you think about it, it's like Frank has divided the workload into 5 pieces, and in each hour he can do 1/5 of the job, and in 2 hours he will do 2/5 of the job. So usually when they give us the time to do the work, like in this case 5 hours, then we simply get the reciprocal, and that will be 1 over 5, the reciprocal of this, and that will be the rate. Another way of figuring out the rate very quickly in the exam is as such. This is 5 hours per job, one job. You flip it, and you get 1 over 5 of the job per hour, and that will be the rate. Now we do another example. Here, example 2, we have 2 guys doing the work. Kim takes 6 days to prepare a boat for use. Dick takes 8 days to prepare the same boat for use. How long will it take to prepare the boat if they work together? Here we have the time for the first worker, and here we have number 1 worker, and we have work, rate, time, and number 2 worker, and he has his work, rate, and time. And now we want to see how long will it take to prepare the boat if they work together. So here we have the combined situation. The work is still the same, but here we have a combined rate when they're working together and a combined time. Obviously, the rate of doing the work when they are working together is going to be faster. So it's going to be more than any of these two. And the time it takes to do the work will be less than the time that it takes each one of them to do the work alone. So here, since this guy takes 6 hours or 6 days to finish the work, his rate is 1 over 6. And here our units are days. And the other fellow will take 8 days, so his rate is 1 over 8. Now the combined rate is their sum. So if I want to get the combined rate, I simply add 1 over 6 plus 1 over 8, and that will give me, here we have the least common denominator is 24, divided by 6, that's 4, divided by 8, that's 3, and that will be 7 over 24. Now we would like to get the combined time, and that's x. Applying now the formula, again the work here for all of them is 1. We're doing one job. Applying this formula, 1 is equal to the rate times x, the combined time. And we solve and we get 24 over 7. That's the time it takes them to finish the job together. And in the book they have a different way of doing it. We'll go over it. I prefer this method, but you can choose whichever way you want to do it. In the book, they say the combined time is x. So let's find out how much this guy can achieve in this framework, x. And so we apply the formula, W equals RT, and how much work you can finish is 1 over 6 times x, and that will be x over 6. The other guy the same, he will finish x over 8. Together, they will finish one job in that time. So x over 6 plus x over 8 equals to 1. And if you solve this as they have done in the book, you're going to get the same answer as we did before. And with this, we come to the end of this session, and we hope to see you again.